Okay, in your assignment, it was numbers 47 to 52. It said find an interval for theta in which the graph is traced only once. And you were allowed to use your graphing calculator. So I typed, this is number 50. I typed in number 50 and I hit graph. And I might need to zoom out a teeny bit, but I don't know, it's making petals, but it doesn't quite look complete. Because the ones that had petals, they like looked like a flower all the way around. This looks like a poor little flower got plucked. He loves me not. Right? No? Okay. So anyway, what you can do is you can go to your window and see the theta min to theta max. That's right now from 0 to 2 pi. I can change that to whatever I want it to be. So I'm going to go down and I'm going to change my theta max to be higher. So it's at 2 pi right now. I'm going to change it to 4 pi and see if that, no, I'm going to change it to 3 pi and see what that does to my graph. I guess I should have adjusted my window. Okay, so it got me to here and it still is not quite a complete flower. So maybe I'll go back to my window and I'll change it to 4 pi instead. Let me just fix this here. Oops. There. And now it looks like a complete flower. Now, if I were to change it to like 5 pi, I wouldn't really notice it doing the last little bit because that's when it's going to start tracing. So for that section of 47 to 52 on the assignment, you're just supposed to play around with the window until the thing looks complete. And then you can check on the answer key to see, oh yeah, I did it right. Or, oh no, I went too far. Maybe it was 2 pi and you went 2 times around and you couldn't even tell. So just check with the answer key. But that's what you're supposed to be, just playing around with the window and the theta on the window for that. Okay. Today's notes are the rest of 10.8. And this is something that's not in the book. And it's called normal form and applications. And it's put into this section because it's going to look a lot like the stuff that we've been doing for a long time in here. So a normal is a line that is perpendicular to another line, to a curve, a surface. The normal form of the equation of the line is written in terms of the length of the normal from the line to the origin. And this form uses trigonometric functions of the positive angle and the normal, and it makes the positive angle that the normal makes with the x-axis. So the normal form of a linear equation is x times cosine, and that is not a theta. It's a different Greek letter. Try to get my stylus working here. Oh, I'm on. That's what's wrong. Thank you. It's phi. Okay. So x cosine phi plus y sine phi minus p equals 0. And then the phi, that's just a different Greek letter. It's still going to represent an angle. It's the angle that is formed by the, it's the positive angle that is formed by the x-axis and the normal. And then P is the length of the normal from the line to the to the origin. I can't read today. I do want to make a comment about distance, as you haven't taken geometry for a while. So if this is the line and this is the origin here, could this be the distance? Could that be the distance? Nobody's answering. Could this be the distance? What? What, Sam? I couldn't hear him. I can never hear what he says because he's quiet. I still can't hear you. I'm sorry, I really can't hear you. You want to say it? You said neither of them are right, and then what did you say? They need to be perpendicular to make distance. So the one thing you need to remember from geometry, not the one thing, one of the things you should remember from geometry is to be distance, it has to form 90 degrees between the object and the line. It has to form 90 degrees. So if we don't have that perpendicular there, that's not distance. That's just a line. And then here's a picture of, oopsies, of a norm, the line, the ordered pair, P cosine phi, P sine phi, where P is the distance from the origin to the norm. And then the phi is the positive angle formed with the x-axis and the
Here's what I found online.
okay. So example 1, write the standard form of the equation of a line for which the length of the normal is 3 and the normal makes an angle of 60 degrees with the positive x-axis. So here's the formula. So we're going to do x cosine 60 degrees plus y sine 60 degrees minus, and then P is 3. Now that is not the final answer, but that should look a lot like the things we've been doing in here lately. Yeah, kind of. Okay. What is the cosine of 60? 1/2 plus y times the sine of 60. Radical 3/2. We are writing this in standard form. And here's a rule about standard form that maybe you do or maybe you do not remember. Let's see if anybody can do it before I... Do you guys remember anything about standard form? You can't have fractions. Who was that? Who was that? It was a girl. Oh, good job. Good job, Megan. So I'm going to multiply both sides by 2. And then we've got, nope, x plus y times square root 3 minus 6 equals 0. Now, when we were doing standard form, like in chapter 1, I was writing it this way, which is a completely acceptable way of writing standard form. There's another way to write standard form. This is also a completely acceptable form for standard form. In this section, they're using the second one. These two forms are not equivalent the way that you see them right now, though, because if I were to move that C over, it would turn into be a negative C. So at this moment, I can't say that they're completely interchangeable, but they're going to use this one. So when we see the C, it's going to be a plus C using this formula here. That's why I have this one equal to 0. Okay. And the reason why that sign does matter is if we're going to convert from standard form into normal form, then we need to know the sign of the C. The sign of the C is going to determine what we're going to divide each term by. This says to divide each term by plus or minus square root a squared plus b squared, where the sign is opposite of the sign of C here. Yes? Yes, the A does need to be positive. Thank you for bringing that up. I should have said that. It was positive, right? Yeah, okay, just make sure. He's just bringing that up. Okay, so in order to convert from standard to normal form, we have to divide each term by square root a squared plus b squared, and then the sign that we choose is opposite of whatever c is in the equation. So that's why the sign of c does matter. And then if we need to find p, it's going to be that last number. And since p is distance, it's going to be the positive version of that, even if it says minus that number. And to find the actual angle at which it rotates from the x-axis, then we'll do inverse tangent b over a, which is, again, the same stuff that we have been doing for quite a while. So write the equation 2x minus 5y plus 3 equals 0 in normal form. And then we're going to find the length of the normal and the angle it makes with the positive x-axis. So I'm going to start by looking at c, and c is a positive. So I'm going to use negative square root. 2 squared plus 5 squared, negative 5 squared, doesn't matter. And I get 4 plus 25. So I get negative square root 29. And then we're going to divide this standard equation. Each term we're going to divide by negative square root 29. Okay, once I divide those terms by negative square root 29, that is the normal form of the equation. That's it. So our p-value comes from the last number. I'm going to ignore the negative because p is always positive. And it would be 3 over square root 29. If we rationalize that, 3 square root 29 over 29. Or equivalent. The phi is tangent inverse. And we can do b over a. You could also use the normal equation to do like 5 square root of 29 over negative 2 square root of 29. But if they're both over square root of 29, then the square root of 29s will cancel. So just doing the original negative, well, sort of doing the original, I should say. Negative 5 halves. And then we're going to get an approximation. I'll let you guys, let's do it in degrees. But I'll let you change your calculators over to degree form, and then I'll get the answer from one of you. Do you have a question?
I don't know if it's just my notes, but like stuff keeps popping up in the blanks, and it's like your word. Yeah. It's like I don't know what it is, but stuff is here popping up.
Right. So what I did was I didn't erase. I colored over what was there before.
Oh, so we erased over it.
Oh, because you're erasing. Well, I thought when I saved it, it wouldn't go back to that.
Did you download it or did you just save it?
I saved it and downloaded it to my computer, and then I uploaded it from my computer. So the work is the same underneath, except that's not my work. And the person who did that work has a mistake. So instead of us fixing the work, I just was like, we'll start over and we'll do my work. I apologize. I honestly thought that wouldn't happen. I didn't have a Word file. I only had a PDF, so I had to like erase it. Well, I saw that it did that, but I thought it was just because it was mine, not because it was the one you guys downloaded. Sorry, guys. Technology is hard. It wouldn't do that if this was just paper. Okay, did somebody get an answer? I don't have the answer anymore. I guess I could erase it and find the answer, but except I can't because that one's wrong. If you erase it and look at the answer that's there before, that one's wrong. So the person didn't put 5/2, they put 2/5 by accident. That's what happened. But it's definitely not my handwriting. You can look. What am I trying to do? Second tangent. Barry, did you get an answer yet? What'd you get? No, give me the answer your calculator gave you.
Like it was negative 68.
Yeah. Negative 68 point what?
Yeah. Well, that would be 0.2.
0.2. Okay. Okay, now we need to talk about the quadrant, because the quadrant is going to matter because tangent can be negative in two quadrant. Well, yeah, tangent is negative 5/2, which could be negative in two different quadrants. The negative 68 puts it into the fourth quadrant, but that doesn't necessarily mean it's definitely that one. So this is how you tell the quadrants. You're going to go back to this norm equation and you're going to look at this right here. Oh, I forgot to write a y. Nobody told me. I forgot my y. There we go. We're going to look at those right there. And this in red, that is the answer to the cosine of phi. And in red here, this is the answer to the sine of phi. So the cosine is negative and the sine is positive. So the cosine is less than 0. The sine is greater than 0. So that would be in the second quadrant. So now I'm getting that from the norm, because if you go all the way back to the original question, it's going to be different, because when we divided, it changed all the signs. So you want to use the norm for that one. And then that's quadrant 2. So negative 68.2 is in the fourth quadrant. How do I find the positive version, but in the second quadrant? Add what? Louder? Pi. Yeah, so on your calculator, plus pi. No, that didn't work. Plus 180. That's why it didn't work. Good try, though. Plus 180. Now, if we were in radians, then we would add plus pi. So is it like 1, 2, 3? What'd you get? Abigail, did you get it? Did you get the first thing? Okay. You just add 180 to it, please. Oh, I'm sorry. I didn't listen. Oh, it was somebody else. She's done. 111.8. Good. So that's the answer to the phi. All right, so those are the three things that we were asked to find for that one. All right, next is the norm. The normal form is a way to find a linear equation from a polar form. The polar form of an equation where p is the length of the normal and phi is the positive angle between the positive x-axis and the normal is, we've got p equals r times cosine theta minus phi. So here's our example 3. Write 3x minus 4y plus 5 equals 0 in polar form. So we're going to go through the normal form to get to polar form. So first of all, let's find the normal form. So to do that, we're going to decide by the c value being positive that we're going to use either positive or negative square root. It's going to be negative. It's going to be opposite of whatever the c value is. And I'm doing 3 squared plus 4 squared, so I get negative 5. Then I'm going to divide everything by negative 5. So after I divide everything by negative 5 and I simplify, I get negative 3/5 x plus 4/5 y minus 1 equals 0. So our p-value is Bless you. P-value is 1. And then we need to find the phi, which is inverse tangent. And then we go and we use, well, you can use these numbers here, or you can use these numbers here. It doesn't really matter. I'm going to use the ones before I divided. So I'm going to do negative 4/3. So I get negative 53.13 degrees. And then I have to think about the quadrant from the norm form. So cosine is less than 0, sine is greater than 0. That's going to put me in quadrant 2. So this is exactly like the one we just did. I'm going to add 180. And our phi is going to be 126.87. So it was all the stuff we just did. Now we're just going to use this formula, which is P equals R cosine theta minus phi. So P is 1. R cosine theta minus 126.87 degrees. So that's polar form. Okay, example 4 is right. 1 equals R cosine theta plus 30 degrees in rectangular form. So I'm going to have 1 equals R cosine theta minus phi is our formula. And it doesn't start with 1. I lied. P equals is our formula. Sorry about that. So what is our p-value? Oh, okay. And then our phi is negative 30 degrees. So we will have x multiplied by cosine negative 30 plus y multiplied by sine. I don't know why I put a parenthesis there. Negative 30 How will I know if it's plus or minus? Maybe. Yeah. Is there anything I could simplify from this? Everything? Do you guys remember your identities? What's cosine negative 30 the same as? Cosine 30. And cosine of 30 is? It's radical 3 over 2. Oops. What's sine negative theta? Sine negative 30 the same as? It's the same as negative sine 30. So we'll have minus a half y. Minus 1. Is that it? Well, it says rectangular form, so technically this could be it. But if we were doing standard form, it doesn't say put it in standard form. If we're asked to put it in standard form, this would not be okay. So I'm just going to go ahead and put it in standard form by getting rid of the fractions. Why are you bugging her? Because your friend that you used to bug left. Yeah, the next she weren't choice 1, but next best, huh? All right. This is the last one that it wasn't there at all. So if you hit erase here by accident, nothing will happen because it wasn't there to begin with. I don't know. It might erase the words I typed on there, but so this is from section 10.1. So we haven't covered it, but it ties in with all of this stuff. So we're going to find the distance between just a point and a line in general. And there's a formula for that. And it is D equals, we do absolute value, A x sub 1 plus B y sub 1 plus C all over square root A squared plus B squared. And to do that, you will be given a point, or you will be able to find a point, x1, y1, and a line, ax plus by plus c equals 0. So here's our example 5. Find the distance between the point 4, -1 and the line y equals 2x plus 1. All right, so the first thing that I'm going to do is I'm going to look to see that we have a point. We do. Check. That's our x1, our y1. Do we have an equation of a line? Sort of. We do. But it's not in the form that I would like it to be in. So I better change that form. How? Jack, how can I change the form y equals 2x plus 1 into the form that I need it into? Okay, well, I'm asking this equation here, how can I make it look like it's in that form? I think you're thinking way too hard about it. Sanjay, can you help him? So yes, is there a way to do it faster and less steps than the way that you said? Subtract the y. That's the way I would do it, but you could do it the other way too. I just try to do as little as possible. So subtract the y from both sides. And then we will have 2x minus y plus 1 for that equation. So I'm going to do the distance equals absolute value. Now we're going to do our A value, which is 2, times our X value, which is 4, plus our B value is -1, times our Y value is -1, plus our C value, which is 1, over square root A squared plus B squared. So A is 2 and B is -1. Did I do this wrong in my other class? I feel like I did it wrong. I did it wrong in my other class. Huh. Oops. I didn't record it though. There's no proof except for I just put it on the video. Yeah. Nobody said anything. Oh no, I don't know what it was, but I had, for some reason, I had 8 plus 1 minus 1 on top. So I don't know if I just wrote a -1 over here. I don't remember. I'd have to go back and look at the notes. So I have 10 over square root 5 for my distance. That could be 10 square root 5 over 5, or we can approximate that distance by typing it in our calculator. 4.47-ish. So either of those is fine for the answer. Okay, and then the notes are on the same sheet as the assignment. So you guys have that assignment to work on. I wanted to just give one thing. Well, there's a few reasons, but one reason why I just wanted to like do one thing today is because you guys also have that weekly review due, but I did extend that through tomorrow because I don't have a way for you to submit it yet. And I didn't want to make it something that was going to take you hours to submit because there's a lot of questions on there and some of them would be difficult to type in. So I just hadn't done that yet. That's why I pushed it back a day. Also, we have that assignment that's due today, which I figured some people had questions on, which in my first bill they did. And then I did put up a new weekly review that'll be due next Tuesday. We are finished with chapter 6 / the little bit of 10 that we did so far. So we're going to be reviewing next class for a test next week. Okay. So that's another reason why there's nothing else today. I mean, I'm not going to jump into a review today. We'll review next class. If you guys have any questions, let me know. If there's any conferences we haven't done,